we are going to be taking another popularly tested topic we're going to be facing in your exams, which is on trigonometry. And I'm sure everyone here has quite a foundation in trigonometry. And even if you have a big foundation in trigonometry, do not be bothered because we try to touch as much as possible. But don't expect us to be able to touch every single part. But yet, we'll try and touch as much as possible. Yeah, let's even introduce ourselves to trigonometry. When you're working with trigonometry, what you basically majorly involves sine, cosine, and tangent. Basically. Then for the later part of this class, we begin to see something like secant, cosecant, and cotangent. But that's still the later part of this class. So for now, we're going to be focusing on sine, cosines, and tangents. Yeah, basically, when you're working with trigonometry, angles are what we work with in trigonometry. And you need to understand that the sine of an angle, let's say the angle is theta, is the opposite side to that angle divided by the hypotenuse side to that angle. And the cosine of an angle, theta, is equals to the adjacent side or adjacent side divided by the hypotenuse. And same goes for tan theta. Know that tan theta is equals to the opposite side over the adjacent. So basically, if we have, and please, this basic trigonometric ratios that we have, I call them basic trigonometric ratios. These basic trigonometric ratios that we have apply to only right angle triangle. Yeah, we still have more trigonometric ratios for non-right angle triangles where we have the sine rule and the cosine rule. But basically, this applies to only right angled triangles. So you have to keep it in mind. Only triangles with an and if I am right, you should know what the right angled triangle is. Just in case you don't know, a right angled triangle is a triangle with an angle of 90 degrees. Okay. Are we together? So that's a right angled triangle. So if you have, let's say a right angled triangle, and one of these angles can be theta, either this or this angle. Now let's take this angle to be theta. This would be the opposite side to the angle. Whatever the angle 90 is facing will be the hypotenuse side of the angle, and the last side will be the adjacent side of the angle. What if for the same triangle, we have the angle at this side, then this would be the opposite side. This would be the hypotenuse. Well, because angle 90 is still facing this direction, and this would be the adjacent side of a triangle. You need to understand this very, very carefully. Yeah, something else you need to also remember for right angle triangles is the Pythagorean theorem. The Pythagorean theorem. Or what you call the Pythagoras theorem, still the same thing. What does the Pythagorean theorem tells us? That the hypotenuse squared is equals to the opposite squared plus the adjacent squared. You need to remember this for basic trigonometry. And if you remember this for basic trigonometry, you would be fine. So basically, let's say we have a right angle triangle with, let's say, the angle here being, let's say, 30 degrees. And we are given, let's say, this side to be 6 meters, and we're told to find, let's say, this point. You just need to understand what trigonometric ratio can I apply here. And there's a mnemonic, we use in secondary school to remember this, and we call this mnemonic SO-CATOIS. So S being sine, O being opposite, H being hypotenuse, C being cosine, A being adjacent. You know what H means, hypotenuse, and T being tangent. How does this mnemonic work? You just have to determine which two sides do we have in the diagram. And if you look at this particular diagram, taking angle 30 as the reference angle, we have a side opposite to it. So we have the opposite, and we are looking for the hypotenuse. So I just have to come back to this two-card mnemonic and see which of these trigonometric ratio has opposite and hypotenuse. And if I have done the right thing, I know it should be so. That it should be sine. Therefore, I could say that the sine of 30 is going to be equals to the opposite, which is 6, divided by the hypotenuse. Now, because you'll be writing JAMB exams, you'll not be given trigonometric, you'll not be given scientific calculator, basically, or calculators capable of performing trigonometric ratios. So, there is need for you to understand trigonometric ratios of basic angles. And when I mean basic angles, the angles that will be tested are 30 degrees, 45 degrees, 60 degrees, 90 degrees, and 0 degrees. Are we together? I would have told you to learn, 15, 30, 45, 60, 75, 90. But from experience, what most examiners will bring out will be 0, 30, 45, 60, and 90. So let's quickly do this. Let's call it special angles. And you have to cram this. You have to cram the sine of 0 is 0. The sine of 30, I'll do for sine, I'll do for cosine, and I'll do for tangent, is 1 over 2. The sine of 60, let me do the sine of 45 first. The sine of 45, you have to know all of these angles off by heart. You should be able to know, remember these angles without any book. The sine of 45 is 1 over root 2, or you can call it root 2 over 2. If you rationalize the sort, both of them are the same. The sine of 60 is equals to root 3 over 2. You can't rationalize because there's nothing to rationalize. And the sine of 90 is equals to 1. You have to remember this for sine. The cosine of 0 is 1. Cosine acts inversely to sine. So therefore, cosine, y sine goes from 0 to 90, cosine goes from 90 to 0. Therefore, sine 0 would be exactly the same thing as cosine 90, and cosine 0 would be exactly the same thing as sine 90. Well, because they go in opposite side, cosine 30 would be exactly the same thing as sine 60, which is going to be 3 over 2. Cosine 45, look at it, because they would both meet at the midpoint. They will have exactly the same value, 1 over root 2. Cosine 60 is going to be the same thing as sine 30, 1 over, because if I go 60 away from 90, I'm landing at 30. So I have 1 over 2. And cosine 90, definitely you should be able to get this. It's going to be 0. Well, tan is the only bastard in the family. It doesn't follow the laws of the rest. What about tan 0? The question is, can I have a tangent of 0? Yes, I can have a tangent of 0. Well, for tangent, things don't always go normal. But you should know that the tangent of 0 is 0. Let's start from that. What about the tangent of 30? The tangent of 30 is 1 over root 3. Are we together? It's not really difficult to understand. You just have to cram it. You just have to cram it. If you can cram it, then you don't have the problem. If you can't cram it, there's going to be very, very big problems. It's a very big problem. A very big problem. Alright. So 1030 is 1 over root 3. Then 45 is going to be equals to 1. Tan 60 is going to be equals to root 3. And tan 90 it's not possible. You cannot find the tan of a number that is 90 degrees. So tan 90 is undefined. You can't find it. You can't find it. You just can't find it. So you have to, I don't know how you want to do it, but it's not really, really hard to cram. To cram sine and to cram cosine is easy. Why? Because you understand they work opposite to each other. If I know sine 0 to sine 90, then I definitely know cosine 90 to cosine 0 because they're exactly the same thing. Sine 0 to 90 in upwards order is the same thing as cosine 90 to 0 in downwards order. Did you understand it? So if I can cram for sine, then I've crammed it for cosine, then I just have to put an extra effort to cram for tangent. Alright, so let's go on. We know that sine 30 is equals to 1 over 2. If you just come to your special angles, so I can say this is similar saying 1 over 2 is equals to 6 over x. You cross multiply, and you have x is equals to 6 into 2, which gives us 12. Easy, easy. Let's take another very basic question on trigonometry. Let's say I have another triangle. And I have, let's say here to be 90 degrees. And I have here to be 45 degrees. Sorry. So I'm waiting for share. So I have this angle to be 45 degrees. And I was told to find, let's say, this angle, x. And I was given, let's say, here to be 10. I just have to think about what can I use. Don't forget, this is facing here, so this has to be the opposite to the angle. Whatever angle 90 is facing is the hypotenuse. Definitely, this has to be the adjacent. Now, I am given the adjacent, told to find the hypotenuse. What trigonometric ratio has adjacent and hypotenuse? It has to be CH, which is cosine. And you know that the cosine of an angle, and the angle here is 45, has to be the adjacent, then divided by the hypotenuse, the unknown. And what is cosine of 45? You should know that that's 1 over root 2. It's going to be equals to 10 over x. Then you cross multiply. Therefore, x is going to be equals to 10 root 2. That's our answer. So look at it. Basic trigonometric ratios is very, very easy once you know your angles, and you'll be fine. Let's do something that has to do with basic trigonometric ratios, and it has to do with something called angle of elevation and depression. This has to do with basic trigonometric ratio. What is elevation of depression? Take a person, for example. Imagine this beautiful girl is standing outside. She's just taking a cool breeze. This would be the normal line of sight for her if she was standing and taking a cool breeze outside. But if she looks up to see a fine boy on the top of his, probably on the skyscraper or on the terrace of his house, her eyesight would have to adjust from the normal eyes, from the normal level to an elevated level. Let's say this is the boy. The boy is putting on glasses. The boy is chilling, hands on the window, and chilling, standing. So our eyesight has to elevate from the normal eye level to an elevated level. And the angle between the normal level and the elevated level is called the angle of elevation. Did you understand it? So if you move your eyesight from the normal level to an elevated level, then you have made an angle of elevation. Something else you need to know about an angle of elevation is, if two people are looking at the same object from different distance on the plane ground, let me show you this. Let's say I have a pole and I have a bed on the pole. Come in. I'll draw the pole for you. Let's say I have a pole and I have let's say this is a pole. Or let me even try and make it a straight line. Let's say I have a pole. Let's say this is a pole and I have a bed. Forgive my drawing of the bed. I have a bed flying or standing on this particular pole. If persons A was standing at this particular point and persons B was standing at this particular point, if both of them looks at this same bed, what would their level of eyesight look like? The first person is going to be having his eyesight looking like this. Making an angle of elevation. Let me use yellow to draw the level ground. Sorry, I want my line to be straight. No, it's going to be straight. Sure. What's wrong with my tablet? No, but you could manage that line. That's quite a straight line. Yeah. If basically let's say this is the level ground. If persons A look at this bed, this would be his eyesight level. If persons B look at the bed, this would be his eyesight level. What did we notice? They have two different angles of elevation. Yeah, they have two different angles of elevation. And what did we notice? This angle would be smaller than this angle. Why? This person has to take his head more high to be able to see the bed compared to person A. What if there is a person C standing here? If he wants to look at the bed, now he has to take his own head way high. Let's call this gamma. Now person C has to take his head way high, which means I can say theta is less than alpha, which is still less than gamma. Forget the symbols. I'm just using them to represent angle. And what does this insinuate? The closer an observer is to an object, the greater the angle of elevation. Okay, I think I need to add only one thing. The closer an observer is to an object on the x-axis. That's a very, very important part. The more you are close to an object on the x-axis, the greater the angle of elevation, and vice versa. Which means the farther you are from an object on the x-axis, the lower the angle of elevation. So should you have a question whereby they are giving you two people's angle of elevation and they don't state who's have the higher, you just have to look at who is standing closer to the object on the x-axis. Then that person must have a higher angle of elevation. Let's put it into a practice. Let's say persons A and B observes the bed on the pole with angles of elevation 20 degrees and 50 degrees respectively, or just 20 degrees and 50 degrees. Persons A stands, let's say, 20 meters away from the pool, and B stands 5 meters away from the pool. How high is the pool? Here, if we try to graph this, we have like an example of the graph here. Okay, let me try and make the graph. Don't let me be lazy. Yeah, so let's say this is, we don't know who is farther away from the pool. I said A is 20 meters away. Let me just automatically draw two angles of elevation. I will automatically draw two angles of elevation. Let's call this person A and person B. How do I know person A is standing there? Because A is 20 meters away from the pool, which is farther than 5 meters away from the pool. So we can say this B to the pool is 5 meters. Then A to B is 15 meters, which makes the entire thing 20 meters. Does this make sense? Yeah. And they told us that the angle of elevation individually is 20 and 50. The question is, who has 20? Who has 50? Don't forget. The person who stands closer to the object on the x-axis have the higher angle of elevation. Therefore, B must have an higher angle of elevation. Therefore, the 50 has to belong to B and 20 has to belong to A. What are we told to find? How high is this pool? Are we together? Now, to solve this kind of question, we can use two ways to find the question. We could pick any of the two triangles. Let's call this top and let's call this bottom. We could either use triangle ACB, the entire image, or we could use triangle, okay, let me call this, no, I can't call this because we have two B's. Let's call this origin. So we can either use triangle ATO. For those that don't know what ATO is, ATO, that triangle there. Do we understand? Or we could use triangle, see this triangle here? Triangle BTO. Sorry, let me adjust the size of this my mark. This my brush. So I could use this triangle to find the height of the pool, or I could use the entire thing. I don't know, my system has been like dragging lately. Let's say we want to use, this is JAMB exam, so if you can visualize the diagram on your head, you don't have to draw. But if you can't visualize the diagram on your head, you can try and draw to make your solving easy. And for those that are not writing math exam, JAMB, they have to draw. So I could say, let me just use the easiest. Let me just use angle ATU. Alright, let me even change this to special angle since we cannot use calculators still. So let me change them to special angles. Let's say this is 45 degrees and let's say this is 30 degrees. I'm changing the question now. Now I could say that from triangle B, or from triangle BTO, I have, look at it, 5 is the adjacent to 45 degrees and x is the opposite. So I have to use the tangent here because tangent is equals to opposite over adjacent, which is equals to x over 5. And we know that tan 45 is equals to 1. Therefore, I can say x over 5 is equals to 1. Cross multiplying x is equals to 5 meters as well. Does it make sense? Now, what if we make the question a little bit harder? Let's make the question a little bit harder. Let's change the values. Let's say we are given the length of the space to be, let's say, 10 meters from A to B. And we are not given this space. And we are told to find the height of the pool and the distance between B and the foot of the pool. How do we find this? Yeah. To find the height of the pool, we need a triangle. But if we try to use triangle, let's say BTO here, we have all the sides to be unknown. And to solve trigonometric ratios, you need at least one angle and one side. So we can't solve it using triangle BTO, right? And if we choose to use triangle ATO, we still have two sides unknown because we don't have the length of AO, but we have, and TO is unknown. So how do we solve a question like this? So whenever you have a question like this, whereby you have two angles of elevation to the same point, and they don't give, one triangle, how do we find it? Call this other place y. Yeah? And establish simultaneous equations. How can we have simultaneous equations? Watch this. From triangle BTO, I know that I am looking for x and y, opposite and adjacent. I'm going to be using tan 45 is going to be equals to x over y. What is tan 45 again? 1. Therefore, I could say 1 is equals to x over y. Cross multiply. Therefore, x is equals to y. Are we good? That's 1. Then I could say from triangle ATO, because you always have to use a right angle triangle, ATO. Yeah. From triangle ATO, the angle there is 30, so I could say that, well, I have AO, which is 10 plus y, and I'm looking for x. I have the adjacent, I'm looking for the opposite, still tan. So I'm going to be using tan 30. Don't forget, opposite and adjacent is only in tan. Did you understand that? So tan is opposite x over adjacent 10 plus y. And what is tan 30 again? You know that tan 30 is equals to 1 over root 3. Is equals to x over 10 plus y. Then if I cross multiply, what am I going to be having? I'm going to be having, well, 10 plus y is equals to x root 3. Are we good? Now I can substitute, let's call this equation 1. I can call this equation 2. Let me substitute for either x or y in equation 2. So I could say sub for, let's say, x in equation 2. So I'm going to be having 10 plus y is equals to y root 3 because our x is equals to y and I'm solving for x. Now I can collect right there. So I'm going to be having 10 is equals to y root 3 minus y. Are we together? I can factor out y from this. I'm going to be having 10 is equals to y into bracket with 3 minus 1. How did I get this? If you remove y from y root 3, you're left with only with 3. And if you remove y out of y, that's y divided by 1. That's y divided by y. You're left with 1. So we have y into brackets with 3 minus 1. Now I can divide both sides by root 3 minus 1. Therefore, I'm going to be having 10 over its 3 minus 1 is equals to 1. You could do this in your calculator to get decimals, but we want to avoid decimals while working with special language, because they give you special language for a reason. Now, what did they ask us to find? Y. Automatically, we have found Y, the distance between B and O. But we can't leave a solid at the bottom. We always have to rationalize. And to rationalize a solid, if you can remember from a solid, you have to multiply up and down by the conjugate of the binomial solid. What is the conjugate of a solid? If I have a solid as A plus root B, then the conjugate is equals to this same solid with the inverse sign, which is going to be A minus root B. All you have to do is negate all the visible signs, not the invisible ones, all the visible signs in, let's say, the question. So if I have a solid to be 2 minus root 4, or let's say root 6, therefore, the conjugate of this solid is going to be 2 plus root 6. What if I have just root 3 to be a solid? What will be the conjugate of root 3? Because there is no visible sign, the conjugate will still be root 3. Does it make sense? If I have, let's say 6 or root 6, the conjugate will still be root 6 because there is no visible sign. What if I have 1 minus root 6? Then the conjugate will be 1 plus root 6. If I have root 2 plus, let's say 4, what will be the conjugate? The conjugate will be root 2 minus 4. So I'm trying to negate all the visible sign to get the conjugate. You coming? Alright. Let's go on. So if I rationalize this solid, I'm going to be having, so I'm waiting for my pen to load. So I'm going to be having 10 over root 3 minus 1 times root 3 plus 1 over root 3 plus 1, which is going to be equals to y. 10 times root 3 gives us 10 root 3. 10 times plus 1 gives us plus 10. Add it together. And if I go to the denominator, I'm going to be having root 3 times root 3 gives us 3. Well, root 3 times 1 gives us plus root 3. And just do everything together. Minus 1 times root 3 gives us minus root 3. Then minus 1 times plus 1 gives us minus 1 is equals to y. We are almost done. Plus root 3 cancels out minus root 3. 3 minus 1 is left with 2. So we have 10 root 3 plus 10 over 2 is equals to y. Still not done. I could factor out 10 from the top and I have 10 into brackets. Root 3 plus 1 over 2 is equals to y. Then I could cancel out. And I'm left with, well, y is equals to 5 into brackets with 3 plus 1 meters. Yeah, I found y. Now it's time to find x. Then I can use an equation whereby, look at it, from equation 1, we know that x is equals to y. Therefore, x is also equals to root, or let me write, recall that x is equal to y. We've established that before. In case you don't know where we established it, this is it. So if you recall that, therefore, we can say that x is equals to 5 into root 3 plus 1 meters. I feel like that's not too complex for us to understand. Are we together? We'll still solve a lot of questions, but I'm just trying to introduce you on how we are solving. Okay, let's just solve one more question before we go to depression. Good. Let's take one more question before we go on to explain angle of depression. Yeah, I'm trying to get the question real quick. Now look at this question. They said the ladder is 5 centimeter long. The ladder always goes up like this. They say it's 5 centimeter long. Resting against the wall. Let's say this is the wall. Yeah. Such that the foot makes an angle of 30 degrees with the horizontal. So the foot of the ladder is making an angle with the horizontal 30 degrees. They said, how far is the foot of the ladder from the wall? Ladder, top of the wall. Or let's say the foot of the ladder, let's call this the wall. So they said, how far is F from W? They're asking us to find this point. What trigonometric ratio do we apply here? We have this to be the opposite, which is not given. We have to look for the adjacent. We have the hypotenuse. Which trigonometric ratio has adjacent and hypotenuse? Cosine. Yeah. So we can say the cosine of 30 is equals to adjacent, which is x, divided by 5. Cosine 30 is, yes, it's 3 over 2. You are on point. Is equals to x over 5. So when you cross multiply, you have 5 with 3 is equals to 2x. Are we together? And we can divide both sides. Therefore, x is going to be equals to, well, 5 over 2 root 3. Let's go over it again. Cos 30 is 3 over 2, which is if I'm saying sine 60 times, don't forget, the ladder is 5 centimeter long. So this is the ladder, 5 centimeter. And x is the distance between the foot of the ladder and the wall. To solve this, let me click again and we'll solve it again. To solve this question, we're going to be using cosine. And we can say the cosine of 30 is equals to adjacent x over the hypotenuse 5. If I could say x is equals to 5 cos 30, I think that's going to be faster. And cos 30 is equals to root 3 over 2. Are we together? So the same thing as saying 5 over 2 root 3. That's the answer. And the correct option here is option C. Option C says x is equals to 5 root 3 over 2, which is exactly the same. Yeah, quickly, before I end this class, let me explain how depression works. For depression, you are at an elevated ground and you are looking below, not above. This is your normal eyesight. Now, rather than looking up, you are looking down. So there's a drop in the angle of elevation. This is the angle of depression. I really apologize for that. So this is the angle of depression. Now, how do we solve angle of depression questions? We have to start in getting a knowledge of alternate angles. Why? You get that right now. Imagine I was standing on a pool. Watch this. Imagine I was standing on a pool. Let's say this is a pool. And this is my normal eyesight level. I'm using dotted lines. And I looked at a rat trying to run into someone's house. Please, imagine this is a straight line. In your eyes, this is a straight line. Good. Now this is the angle of depression. Let's call it theta. But the problem now is, theta is not in my triangle. And for me to be able to solve, I need the angle to be in my triangle. So I have to pull back my knowledge of alternate angles. Because the sky is parallel to the ground. This theta, or your normal eyesight level, above the ground is parallel to the ground by default. Therefore, we can always say this angle is alternate to this angle. Are we together? Another way we can do it is by finding the remaining angle, alpha. And how can we get this alpha here? Alpha is equals to 90 minus theta. How do we know this is a right angle? If the entire right angle is 90, how do I get only this place? I just have to remove this place and I get the length. So I could either do, let's put it in perspective. Let's say I'm standing on a pole that is, let's say 20 meters long or 20 meters high. And I make an angle of depression as I look at a beautiful lady walking down the street. Yes, forgive my share. My triangle looks very good, but you understand it. Yeah. Let's say my angle of depression is 20 degrees. Two ways I can solve it or solve any questions. Let's say I'm told to find here or here. Two ways I can solve this question is to find the remaining acute angle here by doing 90 minus 20, which gives me 70. This is option A. I could do this. If I don't want to do this, I could also do the alternate angle that if here is 20 degrees, here must be 20 degrees. And once I've done that, I'm already done. I can start solving because I know how to solve sides of a triangle if I've been given the right amount of information. So if I want to find x and y from here, I could just say, well, 20 is the opposite, x is the adjacent. I could say tan of 20 is equals to 20 meters over x. And then we change this 20 to a special angle, please, because we are doing JAMB exams. We are going to be working with only special angles. Let's say sine let's say 60 degrees. So we are going to be having the tan of 60 degrees is equals to 20 over x. And if you can remember, the tan of 60 degrees is 3 is equals to 20 over x. So I could cross multiply and say x with 3 is equals to 20. Then divide both sides by root 3 to make x stand in middle. Therefore, I can say I'm having x is equals to 20 root 3. But I can't say I'm done because I can never leave a sword at the bottom. So I have to rationalize. So my answer is going to be equals to. And how do you rationalize a sword? You multiply by the conjugate. And don't forget, for conjugate, we only invert the visible signs. Is there any visible sign here? No. So nothing is going to be inverted. Do you understand it? So I'm going to be having common times root 3 over root 3, which takes me to x is equals to 20 root 3 because 20 multiplied by root 3 is 20 root 3, and root 3 divided by root 3 gives us root 9, and the square root of 9 is equals to what? 3. And this is our final answer. X is equals to 20 over 3 root 3. What about y? Now for y, I know y is the hypotenuse, and I could use 20, I could use x too, but let me use 20. Y is the hypotenuse, 20 is the adjacent, is the opposite, because the angle is facing it. So you don't get confused. So I have the opposite, and I'm looking for the hypotenuse. Definitely, I know I'm using sine, because sine has opposite and hypotenuse. So I could say that sine 60 is equals to opposite, which is 20 over hypotenuse y. I could cross multiply and say 20 is equals to y sine 60. Therefore, I could say 20 is equals to y multiplied by root 3 over 2. Are we good? Now I can divide both sides by 20. No. I want y to stand alone. Right? So easy way you can do it is multiply both sides by 2 over root 3. Multiply both sides by the inverse of this. So cancel this out. Do you understand this? Root 3 we cancel root 3 and 2 we cancel 2. It's simple maths. Did you get it? So I multiply both sides by 2 over root 3, which becomes 2 times 20 is 40. Which takes us to 40 over root 3 times invisible 1 is root 3 is equals to y. I can't leave my answer like this. I still have to rationalize. So I'm going to be having 40 root 3 times root 3 over root 3 is equals to y, which leads me to y is equals to 40 root 3 over root 3 times root 3 is root 9, which becomes 3. And this is our final answer. Yeah, I would solve more questions in our next class. But for this, let's end it today. Have a nice day, guys.